So for 6b, we are going to be talking about functions some more. So we've been talking functions. We are going to get a little more into kind of how you write it in what's called function notation.
I write in pen.
In pen? Yeah, they're your notes. Will you take your earbuds out though?
Oh.
Okay, so function notation is just, instead of saying like y equals something, it usually starts with, it's called f of x, okay, which we would say is the function of x. Okay, that's how you would say that, or f of x, the function of x. So that's the other way you could say it, f of x. This is not writing very well right now. I'm really sorry. I need a new stylus. So function of x or f of x are the two ways that you could say this. And it's basically, it's the same thing as y. Okay, it's just telling you what x has been to get that y, essentially. So it's like if I had the equation y equals negative 3x plus 1, I could also say f of x equals negative 3x plus 1. Okay, it's just a different way of writing the function, the equation, so that it's in that more function notation. So the function of x equals 3x minus, or negative 3x plus 1 is not any different really than y equals negative 3x plus 1. So don't let that whole f and then parenthesis and then some number throw you off. What they're saying is if we plug something in for x, this is what we would get out from it. Okay, so you're putting the x in, you're getting out the f of x, the function of x. So I'm going to give you a few examples. Example 3 here. And this should help you understand it a little better too, just to see it in more of a like real world setup. So this is example 3 because we did example 1 and 2 on Friday. But this is what it says. The function this just does not like my pen right now. Okay, the function w of x equals 250x represents the number of words w of x, okay? So in this setup, that represents try this again. Maybe this one's working a little better. So it represents the number of words, okay, and that's w. Actually, I'm not going to put a parenthesis around that, so it's going to throw you up. The number of words w of x. Okay, so this right here, w of x, is representing the number of words. That's what that is. So the number of words w of x you can read in x minutes. Okay. So they give you a function. W of x is the number of words, right? W, words. X is the number of minutes for reading those words. So you get w of x equals 250x is your function. I'm just rewriting this. You don't need to necessarily rewrite this right now. But this is the function they give you, okay? W of x equals 250x. The question is, how many words could you read How many words could you read? I'm not going to write could you read in 8 minutes. Okay, how many words could you read in 8 minutes? So look at the equation, look at the way the problem is worded. It says the function w of x equals 250x represents the number of words w of x, so this is your number of words, you can read in x minutes. So we have the number 8 here. How many words could you read in 8 minutes? Where are you putting that? Where x is, right? Your number of minutes is x, so if they told us 8, we're plugging that in for x. That means we can say the number of words in 8 minutes, so w of x is 250 times 8, okay? W of 8, in other words, the number of words you could read in 8 minutes is 250 times 8. That means when I plug an 8 in, so w of 8, I will get how many words? You just plug that into your calculator and you get w. So what this is saying, this is function notation. Instead of y equals 2,000, this is saying the number of words in 8 minutes would be 2,000. Okay, so you would read 2,000 words in 8 minutes. Okay, so are you seeing how it's really not anything different? We're just writing it differently. We're writing it as w of 8 instead of y. Okay? Any questions on that? Okay. I can do another one as long as I'm going to do the other 2 examples, and then if we have time, I'll go back and give you another one like that. Okay? All right. Second type of examples. This is example 4. And it says the domain, which is which letter? X. So the domain of f of x equals negative 1.5x plus 4 is, and here's your brackets because this is a domain, 1, 2, 3, 4. Okay, so the domain is 1, 2, 3, 4 for this function. Find the range. What is the range again? It's the y, right? It's the y points that you come up with. So if we are given the x and we're trying to find the y, what do we have to do? Plug them in, right? You plug in all of your x values. So 1, 2, 3, and 4 are going to get plugged in for x. Here's what that looks like. If I have f of 1, what I'm saying is I'm plugging 1 in for my x value. So I would do f of 1, and you come back up here, negative 1.5 times 1 plus 4. Okay, that means if I simplify it, f of 1 is negative 1.5 times 1 is negative 1.5. If I add 4 to that, I get 2.5. Okay, so that's one of my values. If I plug in 1, I get out a 2.5. Then you plug in 2. F of 2 is negative 1.5 times 2 plus 4. So I get a negative 3 plus 4. What's negative 3 plus 4? Is a positive 1. Okay, so that's my next value. Then I plug in 3. F of 3 is negative 1.5 times 3 plus 4. So you get a negative 4.5 plus 4. So my f of 3 would be a negative 0.5. Okay, and then we do it with 4 because that was the last of our domain. So f of 4 is negative 1.5 times 4 plus 4. So f of 4, negative 1.5 times 4 would be a negative 6. Negative 6 plus 4 is a negative 2. Okay, so if they gave us a domain, right, they told us the domain was 1, 2, 3, 4. my range would be those 4 numbers that are boxed. What do you have to do with a range? Put them in order and what? And no duplicates, right? So least to greatest, no duplicates. So if that's the case, what's my smallest number here? -2, right? So you would go -2, then what? -0.5, then 1, then 2.5. Okay, so you find your numbers. Sorry, that's kind of messy. Let's try that again. Okay, so this would be my range. Sorry, that's a 2.5. It's super spaced out. And that's what they're looking for then. Okay, if it helps you to set it up as a T-chart to see it, you can set it up as a T-chart. Just make sure you write your answer out in brackets like that. Put them in order with no duplicates. Okay? Yes? We're okay with that? Okay, so if they give you a domain, you give them a range. This last one is a little more what? Challenging. Yeah, just more details to it. Okay, so example 5. And I'm not going to write out all the words. I'm just going to write like the key parts for you if you want to write the words out. I feel like I pulled this one right from the book. I'd have to go back and look, I guess. But here's the problem, okay? Gentlemen, it's up here. It says you have 3 quarts of paint. 3 quarts of paint to paint the trim in your house. You know what trim is?
Yeah, like
Trim is like crown molding or baseboards or the framing around the doors, right? That's the trim, okay? On the inside anyway. The outside it would be like your eaves, your all that. Okay, so you have 3 quarts of paint to paint the trim in your house. It says a quart of paint. A quart of paint covers 100 square feet. Okay. The function A of Q equals 100 Q represents the area, A of Q. Okay, so this right here is the area in square feet that a quart Q, or Q quarts, so Q is your number of quarts, of paint will cover. Okay? Here's the question that you need to answer. Actually, no. We're going to answer this question first. What domain and range are reasonable? Okay, so we said that we have an X and a Y, but in function notation, the Y is gone, okay? What's representing my X right now? Is it A or Q? Q would be like our X, right? So that's my domain, okay? So what they're saying is, what's a reasonable domain? What's a reasonable set of numbers? Like, what's the lowest number of quarts? Josiah, put it away. What are you laughing at on your screen right now? Okay, well, just focus for me. What domain and range are reasonable? So what's the lowest number of quarts of paint and the highest number of quarts that you can do? Okay, so think about what the problem said. You have 3 quarts of paint and you're trying to cover all the trim in your house. What's the lowest number of quarts you could use? Full quarts, sure. I mean, if you didn't paint at all, what would you be using? How many quarts of paint if you didn't paint anything? 0, okay? So you can start as low as 0, but how high can you go? 3. You only have 3 quarts to work with. So when they ask what is a reasonable domain and range, our reasonable domain would be anywhere between 0 and 3 quarts of paint. Now the way that we write that is 0 is your low end, 3 is your high end for your quarts of paint. So 0 is less than or equal to the number of quarts, which is less than or equal to 3. Okay, when they're asking what's reasonable, we set it up as a range from 0 to 3. Okay, so for my domain, this is reasonable. Okay, if that's a reasonable domain, now you have to figure out what's a reasonable range. Range is the A of Q or the F of X or whatever. In this case, my range is whatever we're going to get out of that. Now here's how you have to think about it. If my domain is from 0 to 3, then my range would be if I plugged in a 0, what would I get? And if I plugged in a 3, what would I get? Does that make sense? So if I plug a 0 into this function, oops. Oh my goodness. This app does not like me right now. Okay, so let's say I plug in 0. Then I'm doing 100 times what? If this is my function. Times 0, right? If I'm plugging in 0 for Q, it's 100 times 0. So A of 0, if I use 0 quarts of paint, in other words, I would get 0 area covered. Okay? Julia, what are you doing right now? They're for sure watching you instead of me. Like 2 people back there watching you instead of me. Pay attention. We take your earbuds out too. Okay, so A of 0 equals 0. The high end of your range is if you plug what in for Q? So if I plugged in 0 as my low end, what do I need to plug in to get my high end of my range? 3, right? The high end of your domain will get you the high end of your range. So you're going to say A of 3 is 100 times what? 3, right? The number of quarts you're plugging in would be 100 times 3. So if I use 3 quarts of paint, I would paint 300 square feet. Does that make sense? So you're just plugging in your domain numbers to find your range. So the range that makes sense would be as low as 0, right? If I plug in a 0, I get 0. And then this is A of Q. And if I plug in my high end here, I would end up with 300. Okay, so this is my reasonable domain. This is my reasonable range. My domain would be between 0 and 3. My range would be between 0 and 300. Does that make sense? You guys need to wake up today. It is Monday, but holy cow, we got things to do. It's raining, it's Monday. I know, it's rough. Okay, then they ask you to graph it. Okay? When you're painting, do you have to use 1 quart of paint at a time? Or can you use like a half a quart or a quarter of a quart? You can, right? So this is discrete or continuous?
Continuous.
It's continuous to a degree, and then it stops, okay? So it's kind of a combination of the two. But what you're going to do, if you're going to graph this, and if it's helpful to you, I would do a T-chart for the number of quarts and the area that those quarts cover. So we already said if you plug in 0, you get 0, right? If you plug in 3, what did we get? 300. Okay, so plug in 1. If I plug 1 into that function up here, 100 times 1 is 100. If I plug in 2, what do I get? 200. So if I'm going to graph this, you got to make sure you define your variables here. So this would be quarts of paint. This would be A of Q, or your area covered. What would we count by in our quarts? What do you want to count by here? Ones. Count by ones. So if you start at 0, 1, 2, and 3. Okay, what do you want to count by an area?
100.
You can count by 100, you count by 10. If you count by 10, you got to get all the way up to 300. So that probably wouldn't, it would be, you'd have to go really high on the graph. You could, but it would go really high. I would probably just count by 100 since that's what we're going up by anyway. So 100, 200, 300. Sorry, I kind of ran out of space there. And then when you plot it, it's pretty easy. 0, 0, 1, 100, 2, 200, 3, 300. Okay. Now, technically, we said we could connect those, but can I have an arrow that keeps going through it? You have to stop there, right? Because if you kept going, that's saying we have more than 3 quarts. And they told us at the beginning, you only have 3 quarts of paint. Okay? All right.